Hi, everybody. I don't know if you can see. Okay, so today we'll talk about another backport. It's another backport for me because I have already write a backport of the 292 feature. And this is a joint work with Jefferson here. Basically, he does the hard work, and I just put my name on it. It's not Valhalla Backport. It's more specialization backport at that time, which means that we don't support any value type things, only the specialization, basically only the specialization of primitive types. It means, so the journey is to come from here and to be able to go to Valhalla. I know that you are asking yourself a question, why trying to backport something that doesn't exist? Which is a nice question. I think part of the answer is Brian should not have all the fun. The other one is, as I said, I have tried to implement a backport of 292, and it was a good way to try to understand how invoke dynamic had to work. So what we hope with the backport of Valhalla is to be able to gain the same kind of what we can do, what we cannot do. Basically, the idea of if you create a backport, you can't cheat by saying the VM will do that for me. So it's basically you put yourself in a corner and you try to go out. There are two kinds of backport. One is a kind of global backport. You think that you are in a closed world and you rewrite the whole things. Here we try something a little more fun, which is to be able to only, we only need to know either classes that use specialization or classes that declare an any something, which means that we have to be backward compatible with the whole Java ecosystem. We are grown up, so we don't talk about syntax. We reuse the model-free syntax, the model-free class descriptor, which is really nicer than the previous models. And initially, the idea was to not change the semantics too, but it was too tempting to do something. So I will explain why the semantics, it's not exactly the same as the semantics of Valhalla, actually. Basically, the underline is that we think our semantics is better. So what does it mean to be backward compatible? I mean, we have source backward compatibility or binary backward compatibility. Here, we want something more than just binary backward compatibility. Let me try to explain. The question is, what is the relation between array list of int and array list of integer? What is the relation between array list of wildcard and array list of the raw array list. The issue is that people get generics, but in the wrong way. What they get is that you have erasure, and when they use generics, they think in terms of erasure. If we try to provide something that change this model, that change this mental model, it will be hard. I mean, currently, if we do specialization by changing the mental model of the people, people will have hard time to figure out. The main issue is that erasure is already something which is hard. And we don't think it's a good idea to say, oh, you have erasure in this case, but not in this case, and things like this. You have another way to see the things, which is specialization from the user point of view should be seen as an optimization and not as a new mental model. Basically, it means that for the user point of view, generics are not reified. The VM will do things. That's the VM. VM will do specialization. It's an optimization. So what the backport tried to do is to see array list of int as a plain old array list and to see the array list of int code as a specialization. But this is two different nature. Obviously, you can get things like this. So this is how the backport works. The backport shows you just Jekyll and basically hide Mr. Hyde. Let's take just an example. I have an array list of integer. Basically, what is an array list? You have two fields, the array of element and the size. And I'm only interested by one method, add, that is able to add a new, to add an item inside the array list. It should be enough. The question is, what is the representation for a list of int? As I said, the idea is to have two array lists. You have the front class, which is named ArrayList or Java util ArrayList, which is a class which is visible from the user. This class doesn't contain any fields, just one, which is a pointer to the back class. And the back class is the one which is specialized. The specialization contains the field and the code, but not, by example, the static method and static fields that are in the front class. In the front class, you need to be backward compatible, which means that you need to have a method that takes an object as parameter. So even if you specialize the code to have an array list of int. The specialization code will be in the back class, and in the front class, you will still have your classic add that take an object. Inside the front class, all the code, all the public methods are redirected to the back class using invoke dynamic, because the back class is the one which is specialized, so the signature of the thing will change. So this gives us a path. You can think the add in the front class as a kind of bridge that gives you the ability to use array list of int as an array list of integer, because you have this front compatibility layer. So technically, it's not exactly what we generate, and I will step by step give you a kind of tour of exactly the code we generate for it, because it's a little bit complex. First, in the back class, the method has to be static, otherwise you don't have the right this object. So you have to take an array list as parameter, which means that when you try to access to a field, you have to access it using invoke dynamic. Now let's see, in case of array list of int, what is generated. So the front class is exactly the same. I have just duplicated here because it's simpler to see, but it's exactly the same class. And you have the specialization, the back class, which in our case will contains an array of int, and the signature of the method add in the back will take an int as a second parameter because of the specialization. What is nice is that the code that you'd use array list of int is a new code. It's not an old one. So we can use invoke dynamic at call site directly. It's not a code that currently exists. So because we use invoke dynamic, we can bypass the front class and avoid boxing. What the invoke dynamic does is just take a look to the back object, take a look at its class, and just do the redirection. Basically, if you take, we have a kind of invariant, which is the code of the back class is always accessed using invoke dynamic. So we have the guarantee that we will not do any boxing along the path. It means that if you take a look to the front, because you have one code for the front for several specialization, it means that the code that does a compatibility layer has to implement a polymorphic inline cache, because it can dispatch on all specialization. I mean, we use invoke dynamic, so it's not a big deal.
It's still just object and all the primitives, right? It's still just object and all the primitives, so it's bounded.
Yes, yes, yes. Currently, we don't support value type, so it's easier. We still have a trouble with this design, which is it has to be backward compatible with the non-any world, which means that we can have a string array list that extend array list of string, which means that in fact inside array list you can see both world. You see the field of the old world and the back field for the new NFI world, which is not that great, but it seems to be the only way to do the thing. And with this design, we have the nice property to have array list of integer, a list of int, array list of wildcard, array list of nothing that are the same, or that is the same class. How it works at compile time, it's not exactly at compile time, but it's just after compile time, at weaving time. We use a patch version of ESM that recognize the Valhalla bytecode, the model-free Valhalla bytecode, and basically generate the classes of the front and the classes of the back. Technically, we generate not all the specialization. We just generate one class with alls that will be specialized at runtime. We don't need to do specialization at compile time. And we generated front and a back only if the class is anyfied. How we do the specialization of the back class at runtime? Here lies the dragon, let's say like this. You have three problems to solve. How to deal with field and method access, because the signature of method or field will change. How to deal with instruction like loading a local variable, because this instruction is specific to a type. And the last one is how to deal with the size of the local variable. Long and double have a double size, which is awful. So first, the obvious part, which is basically when we generate the back class, we have only one back class. In the constant pool, we use an erased version of the world, and we have a side table which is stored as a class attribute that say for the constant pool entry 2, it's a T, and we will do the substitution using the string substitution. So basically, the model-free bytecode represent parameterized type as a tree, and we flatten the whole tree and do string specialization. It works. And at runtime, we use define anonymous class to load the back class, and patch define anonymous class. The last parameter of define anonymous class is an array of values that will be a substitute, a constant pool entry. So basically, you can do the specialization just by calling define anonymous class. And the whole idea is to not use any bytecode weaving at runtime. So it works well for field and method. It works not that well for local variable instruction, because I can't just say I am the owner of the VM and I will create new bytecode. I have to use the bytecode that already exists. So I need something special. Black magic. So basically, we generate something like this. It's not bytecode, it's not Java, it's just to understand how it works. We generate an if for each specialization for each primitive specialization. So we generate a bytecode that basically check what is the class at runtime and use the right instruction. I have no problem with the verifier. I know, I mean, it's a good friend of mine, and I know how to speak. Yeah. In 2 slides, I will explain how it works. But yes. For the size of the local variable, basically because a t can represent a long or a double at runtime, and I don't want to rewrite the bytecode, I have to use 2 slots for it. It's not a big deal. You just have to renumber all the local variable. It's a little more complex with parameters because the number of the slots for the parameter are implicit and depends on the descriptor, and because the descriptor will change with the specialization. We have to do a little trick. It's not a big one. Basically, if you have the method foo that take a t as a second parameter, t now, the small t needs two slots. So we have a translation between the object world and the specialization world. And we have to add a preamble which is able to basically, if it's a long or a double, we have to do nothing. Otherwise, we have to change the slot. So we generate code like this, basically. If the class is a long or a double, go to end, and otherwise, we have to move the local variable. And that's it. We have solved all our issues. Not really. You have the stack map frame. Stack map frame are generated when you have a join between things. Obviously, it will not work well here. I mean, you will have. We need to generate a stack map frame when you come back from the if of the different type, but here the type will be different at each time. Basically, what we have generated is not verifiable bytecode, so we can use dash no verify, but it's not that fun. No, we need another way to bypass bytecode verification. Okay, question. How to bypass bytecode verification, but for one class? Not. Yes, with define anonymous class. With define anonymous class, you can choose the host class. We use Javalong object. So it's awful, but it works well because every class of Javalong is basically not verified. So so we generate a class using define anonymous class, and you say because the host class is Javalong object, we are saying you don't need to verify it because it has exactly the same security guarantee that Javalong object. Obviously, it has a little side effect. We need to erase all descriptor because Javalong object is loaded by the bootstrap class loader, and the bootstrap class loader doesn't see all other type because these types are only seen by the application class loader or by any user class loader. So we need to erase all objects, all types that are not in Javalong, basically. So it's not really an issue because we have invoke dynamic. We can go back to the right type. We just have a small issue, which is we can't call a bootstrap method because you have to put the bootstrap method in a class, and the class is not visible. Oops. So how we can do that? We need a way to call a method we know. Basically, the idea is instead of using a bootstrap method which is in the application class loader, we will use a bootstrap method which is inside as a back class, so we can see it, but it means that we have to duplicate code, which is stupid. So basically, the idea is the bootstrap method is in the back class, and we call it, but we have still the same issue how to do the call. But because the bootstrap method is inside the back class, we can send bootstrap parameter on this bootstrap method. And because we use define anonymous class, we can patch the bootstrap constant at runtime and send it a method handler, which is already resolved to the right bootstrap method. So basically, with define anonymous class, we insert a special method handle which has already things. The method handle point to the bootstrap method with the right information, which means that inside the bootstrap method, the pink one, we have the lookup of the front class, which means that we will be able to resolve every call as if it was in the front class, and we have the string of the descriptor not erased. And by the way, we stupidly at some point, instead of using a string, try to use a method type, but it was not resolved at the right time. So basically, you can bypass the bytecode verification. It's just painful. It seems to work. I mean, there is really no reason that it works. I mean, it should work with the interpreter. The interpreter just interprets the code. But for the JIT does a kind of static analysis of the code. So we will see that the code is not safe. It's the same with the GC. The GC use type information, which is derived from the class. It's a kind of static, the information is derived using a static analysis too. In fact, it works with the hotspot JITs and with the hotspot GC, but it doesn't seem to work with the IBM one, which sees more information. This is because the JIT of hotspot only take a look to the things that are executed at least once. So it works. Almost. So how to store static fields or spaces fields? It's really easy. You can store static fields in the front class and spaces in the back class. If you have conditional methods, the where clause, it's easy too. You may have a kind of clash if you generate all the things. So we change the name by appending a dollar something at the end. And we, because all the code of the back is called using invoke dynamic, basically what we have done is use a special vtable which is specific to a specialization that does the translation. In fact, we also need this if we want to support inheritance. So, summary. With this scheme, array list of nothing and array list of int are the same class. Technically, it means that you can use array list of int as an array list of integer. It will work, which will be very great. It means that you can incrementally change every list of integer as an array list of int. So not that nice part is that we have to rely on unsafe bytecode. I mean, each bytecode is safe, but the whole thing is not safe. So it's a security nightmare, basically because we use the Java Lang object as the host class. It means that every code which is inified has the same security privilege as Java Lang object. It may not work with all VMs, and it doesn't work with methods that sniff the call site as a call stack, because you have an indirection. So it doesn't work with the context-sensitive methods. The code is freely available here. You have, I think, 2 more tricks in the code if you want to see. You have one which is how to get a lookup of any class if you want, or things like this. And doing this, the thing is, we think that Valhalla should have exactly the same semantics we have, which is, from the user point of view, there is only one Java util array list. And all other things should be seen as an optimization done by the VM and not at something that user can see.